Hey, welcome back. So today is day 2 of the Tinkercad class. I'm here with my student again. So this is McKinley. You ready to go today, McKinley?
Yep.
All right, we're going to do some circuits today. So Tinkercad is built with 3D model support. So that's kind of what we did yesterday with the rocket in the house. It's built with circuits, so you can do things with like simulating circuits, and that's what we're going to do today, tomorrow, and Thursday. And then it's also got this new thing called code blocks. We'll do that on Friday. So today we're going to go with circuits. I'm going to show you the solutions to some things we're going to build. So we're going to build a pretty complex program, just teasing, that has an LED. So we're going to show you the right way to hook up an LED with a resistor so that you can turn it on and off with this button. And that'll make the LED go on and off. And then the wrong way to do it without a resistor. And their little simulator shows disaster, right? So it explodes on you, right? So that's one thing we're going to build today. Another thing we're going to build today, this is the main project, is a stoplight simulator. So I'm going to click on Start Simulator here. And so we're going to write code for the stoplight simulator. And we're also going to build it in a simulated environment, such that if you hit this push button, so when I push this button, my stoplight goes green, and then yellow, and then red. It goes pretty quickly just because it makes the simulation work better. Now, the fun thing about what we're going to learn today is these skills are things that you could transfer to real product, right? So I've got an Arduino Uno here. This one is part of a kit that comes from SparkFun. It's a pretty good kit. It's their SparkFun Inventor Kit. But I've actually taken the code that we're going to write together and I've put it on this real board. And you can see that when I push the button, it does the same thing on a real board. So everything that we're doing in the simulator here is something that if you happen to have the actual hardware, you could totally build, right? So for people that happen to have an Arduino sitting in a closet somewhere, they could do that. By the way, if you did want to buy an Arduino, you could look on Amazon. There's some great kits out there. Elegoo has some cheap ones. The SparkFun one's also awesome. It's just a little more expensive. So let's go ahead and get started. So log in to Tinkercad. Hopefully you know how to do that at this point. And instead of being in the 3D design area, go into the circuits area. Now when you come into circuits, there should be a try circuits like tutorial here that you can get started on. Let's go ahead and go through that tutorial. It's only like 3 or 4 parts this time, so it's much shorter. If you don't have that tutorial, you could always get there via the learn approach and like you could get there, but it should just be sitting right here, which is great. I wish they did that for the 3D designs. I don't know what they didn't. But go ahead and click on try circuits. And what it's going to do is it's going to introduce us to using circuits in a very brief tutorial. So this is their first tutorial. It's very short. It brings up a battery. This one is a coin battery. I don't like coin batteries. They're too dangerous for kids, but they work like any other battery, right? And what this battery is doing is it's going to light up an LED when we start the simulation. Now let's talk about how this works. So we're looking at our project here. So it's kind of the middle area is your board. And then over to the right here, you've got all your components that you can add. So you can bring components over. This one started with components, so we don't need to actually bring anything over. And then over here is just the information for this tutorial. Normally there's nothing over here. And then once you're ready, you can click on Start Simulation. Now Start Simulation is not that exciting. The only thing that happened is this LED lit up, right? And the reason it lit up is because there is a loop of electricity that actually is flowing through this thing. So the battery has a plus here, and so this is the positive of the battery. It flows through a resistor. The resistor determines how bright the LED is, and if you didn't have the resistor, it'd be too bright and it could damage the LED. And then there's an LED. An LED has 2 legs. They're called the anode and the cathode. I won't get into the chemistry of it, but they're called anode and cathode for chemistry reasons, right? And so that electricity flows through the LED, down through this black wire, and then back into the battery. And that loop is what makes the LED come on. Now, of course, if there was a piece missing from that loop, like let's say that wire wasn't there, you'd have no loop, no light, right? So stop simulation. Cool, and so the only thing that this tutorial was trying to show you is how the environment works and to run a simulation, and that's really it for the first tutorial. So I said that there were only like, I think there's 4. And one of them is now done, right? So not too bad. The next tutorial they've got is actually is what inspires the project that we're building today. It's to build a little traffic light program. So here they're connecting to an Arduino Uno. An Arduino Uno is a type of microcontroller. Microcontrollers are in everything. Like if you press like lock in your car, there's some microcontroller that controls the signal. Think of them as like little bitty computers. And so we're going to be programming this microcontroller, which is an Arduino Uno, to do things. And what we're doing here is we want to make, they'll show you a simulation, we want to make a little red, yellow, green traffic light pattern. But right now you can see that all of our LEDs are blue. And so the goal of this tutorial is purely to help you edit the components to actually change these lights to be the right colors. That's all they're doing in this, but we'll look at it a little more than that. So let's go ahead and follow the tutorial and do what it says. It says click on the top LED. All right, and click on the top LED. And then you'll notice that a little box popped up here. And this little box has information about this LED. The most important thing is that it's got a color. And we want to switch the top one to be red. Now the second one down, if you click on the second one down, it is also currently blue. But as you can guess from the wire color, we want to make it yellow. The third one down, hopefully you've picked up the pattern, is connected to a green wire, and it is now green. Now this circuit is actually very similar to the one we saw before with the battery, but it looks more complex. It's just that the Arduino here is better than a battery, because a battery is just always on, whereas the Arduino can make something be on or off, and it picks, right? But pretend like this is the battery for a moment. Current is flowing through this resistor, through this LED, and then to ground. And this ground is just kind of connected between everybody. Yellow is the same way, flows through the yellow and then to ground. And green is the same way, and it flows through here. Now all they want you to do on theirs is to change the color of the lights and hit start simulation. And then it should go green, yellow, red. And then it just loops, right? So it goes green, yellow, red. Now that's all the tutorial is going to have you do. I just want to glance at one more thing before we move on. And so I'm going to click on Stop Simulation. And the way that this whole thing works is via the code that's on the microcontroller. So click on where it says code here. And you can see the code that they wrote for this. You can see it a couple different ways. You can see it as blocks, blocks plus text, or text. What we're going to do, and it doesn't want me to change it, what we're going to do today is we're going to use blocks plus text. And what we're going to do the 2 days after this is just straight text. So we're going to be programming with just straight text. Just to glance at it over here, we're not going to memorize it, but I'm just going to see some things it does. An Arduino program has two functions that get called. One is called setup. It does the setup work to prepare things. And then loop. This is a function that gets called over and over again that keeps going forever in a, what's the word, Sissy?
Forever loop.
Forever loop, yeah. And so right now you can see what they're doing is they're making the 3 LEDs, red, yellow, and green, as output, output, and output. So that's part of the setup. And then in the loop, they're doing different things. So here they're making the green one on, so low, low, high, and then the yellow one on with a low, high, low, and then the red one on with a high, low, low. And then there's a little delay here after each one to make the simulation. So like I said, we're not going to memorize the code, but I just wanted you to have some appreciation for how this thing works and the fact that it's dealing with code. And code is going to be our whole focus as we're working together. But let's get through the simulations, the lessons first. So go ahead and click on Next. And it says that you can change some things if you want, but I think that we'll do that together. So on to the next tutorial. The only thing I don't like about these tutorials compared to the 3D modeling ones, and to the 3D modeling when you got stars, right? The stars went off. You got this warm, fuzzy feeling. Whereas this, there's no stars. Do you miss the stars, Sissy? All right. All right, this next one is connecting wires. So a big part of wiring is connecting wires. And what we're going to do is we're going to connect 2 wires to this circuit. And it shows kind of like a demonstration of how to connect a wire. And so most of this circuit is all built. It does some crazy things with sound. I'll make sure my sound is cranked up for this one. It's going to be great. But it's missing two important wires. The wires that it's missing is the connection to the battery, pretty important. And so what they want you to do is they want you to connect the red terminal of this 9-volt battery up to the red line that's up here. You'll notice that if you look at their circuit, there's a red plus rail, and it's actually connected all the way down. And then there's a red line, which makes it connected to the bottom plus rail down here as well. We'll talk about breadboards more, but the rails that are on the outside are connected all the way down internally, and rails in the middle are connected all the way across internally, right? So to connect a wire, most people, they want to click and drag, and that kind of sort of almost works, but the best way to do it in Tinkercad circuits is to click once for where you start, and then I'm no longer touching the mouse, and then to click again when you get to here. And so that connects the wire with 2 clicks is how it works best. Now let's talk about colors. So wires, you can change colors on wires. The color of a wire is completely meaningless, right? It's just like you spray painted it red or spray painted it blue. It does not matter at all. I like to use colors to make my code easier to look at. So for example, they used a red and a black here, and I just immediately knew, hey, one of these is for the positive from the battery, like the plus, and then the other one, the black, is for the ground. So that's why colors are nice. So we connected that one. And then it says to connect the ground one. So this is the same as what we did before. So we click on the black there. And then you do have to be careful about where it goes to. They want it to go to the black line on the bottom. And then I choose to change that and make it be a black wire. Now, let's try it. And if it works, it should make a bunch of noise. So mine, thankfully, isn't making a ton of noise because of how my microphone's set up. But yours should be making a bunch of noise. All right, Sissy, is yours making noise? Yep. Okay. All right. So it makes some horrible noises when you press the buttons. So I just realized I wasn't even pressing the buttons. But when you press these buttons, it should be like a piano, and each one should make a different pitch. So it's a cute little way to start learning about doing some wiring, but really we just connected 2 wires in the tutorial. The next thing we're going to do is we're going to learn how to get like fancier with adding wires and also to add some components. So this circuit has 2 AA batteries, so that's about 3 volts total, driving a motor. This circuit does work. You can go ahead and test it right now. And what it'll do is it'll spin this little motor. So these are pretty inexpensive motors. It's cruising along at some super fast speed. It looks slow here, but it's just because it's going so fast that it's messing with the frame rate. So it's going super fast, right? So these motors, they spin at like 5,902 RPMs is what mine is doing right now. And what they're going to do in this tutorial is they're going to have you add a resistor, what's called a photoresistor, instead of that bottom wire. So go ahead and do this. Click on the bottom wire, hit delete, and then in your components, scroll until you find a symbol that kind of looks like that. Here it is. So it's a photoresistor. All right, so there's my photoresistor, and then what it tells you to do next is it tells you to rotate it. To rotate it, you hit the R key. So if you hit the R key, it'll kind of rotate it around. If you rotate it too much, that's fine. You can just kind of keep rotating around, or you can hit Shift Rotate, Shift R to rotate a certain way, and get it to where it's roughly located about here. Now what we want to do is we want to connect a wire. Now what we learned before is that you can click here, and then you can click there, and then it'll connect a wire. But if you look at their picture, it's got this cool like bend in it, right? And so how did they get that cool little bend? Well, let me click undo and let me just try it again. So you could click here, and then somewhere down here, and then over here, and it puts a cool bend in it for you, right? But even if you don't do it perfect, that's fine. You can always grab these, they're called handles, and you can move it around to your heart's content. You could also change the color to be red if you'd like. Just to practice, I'll show you another way you could have done it. Let's say that I had moved it from here to here, and I didn't add that bend. Well, what I can do is when the wire is selected, I can double click and add a bend, and then I can just move it to wherever I want. So you can always edit wires, so don't care about if you get them perfect the next time, you get them perfect the first time. Another thing that's nice to do with wires is you can change their colors using hotkeys, and I happen to know that red is the number 2. So I just put my wire on here. I'm going to choose to put it on with no bend initially, and then I'll add a bend after the fact. And it was red because my last wire I put on was red. All right, so let's go ahead and start the simulation with this. So now when I start the simulation, you can see it's going much slower. I should have explained this before, RPMs. This is revolutions per minute. It's a very common unit for motors, RPMs, revolutions per minute. So right now it's going very slow because of this photocell. But what I can do in this photocell, and they show it in the circuit here, is I can change how much light there is in this photocell. And so if this photocell was in the sun, the motor would go very, very fast. So like if you took it outside in the sun, it would just start humming away, right? But if you were in the dark, like inside the house or in a dark room, it'd be slower. And then if you turned off the lights, it would get super slow, right? To the point to where it's only going at 2 RPMs. And the reason for that is that this component called a photoresistor changes its resistance based on how much light there is. And whenever it's dark, it's a really high value, which makes the circuit have very little current flow through it because it's got a lot of resistance. Does that make sense? But again, you can see the path of current flow goes through here, and that's what makes the loop. So the only thing we wanted to learn about is adding components. So you just drag and drop them from over here, and then some extra things about adding wires. Great, so I think that this one is done. So that was it for the tutorials. Those are some pretty easy tutorials. Once you finish the tutorials, there's a button to like go back to the project page. To be honest, where it takes me back to is not the page I really wanted. The page I really wanted, I'm going to click on the Tinkercad logo up here, and this will take me to my dashboard, right? So my dashboard has, of course, the 3D designs, which we made yesterday, and then it's also got the circuits that we're building today. Now mine still has this tutorial here for try circuits. I do not want to click it again. I've already done it once. Instead, what I want to do is I want to say create new circuits. So this is the way projects normally work when you click on create new circuit. There's no like instructions over here. There's just like a blank canvas, right? It does tell you that there's a cool thing called starters. So we'll maybe do that sometime, but we don't really want that for right now. We're just going to click on show me the basic components and we'll do some things together. Now, one thing that's similar to 3D modeling is when you create a new project, it will create a crazy name for you up in the upper left. I'm going to change this one to be called My LED. And what we're going to do is we're just going to practice adding some components and wiring them up. So here's some components we're going to add. We're going to add an LED. So go ahead and drag an LED and drop it onto your canvas somewhere. And we're going to add a resistor. And then we're going to add a battery. So those are the 3 things that we saw before that we used to drive an LED. Before they used the coin battery, this time I used a AA battery. Now what we're going to do is before we wire this up, we're going to change some of the details of these components. The LED can be any color you want. So you can change the LED color if you'd like. So I just click on it and then I can change the color of the LED. The resistor should be a certain size. This is kind of an interesting game, but it can be some number of kilo ohms. That's like thousands of ohms. So right now it's 1 kilo ohm, so that's 1,000 ohms. I'm going to switch it to 330 ohms, right? So first off, right now it's 1 k ohm, but if I were to switch it to ohms here, what I did right there was identical, right? So I can say 1 kilo ohm or 1,000 ohms, and they're the same number. I did this though because I actually want to change it to 330 ohms. So 330 ohms is the correct size for a resistor so that the LED is good and bright, but not too bright. And we won't go into the math, but 330 is a good value. Next up is the battery. So the battery actually has some features we want to change too. The first is the count. I actually want 4 batteries. And then do you want a built-in switch, yes or no? I'm going to say yes. So they actually sell these things where it's like a little 4-pack of AA batteries, and then they've got a little like on-off switch on the top here, which is kind of handy in this case. 4 AA batteries, by the way, each one is 1.5 volts. So 4 of them together would be, Sissy, what's your math skills like?
Let's see here, 1.4 would be 6 volts.
6 volts, that's right. Yep, so 6 volts there. All right, so let's go ahead and hook up this circuit now. So to hook up this circuit, what I want to do is I want to take the positive voltage and connect it to the anode of the LED. And then I like to make my wire be the same color as my LED just for fun. And in this case, it's already done because it's green. And then what I want to do is I want to take the cathode and connect it to the resistor, and then take the other end of the resistor and connect it to the negative terminal. And now what I'm going to choose to do is I'm going to make that side be black because this is the connection to ground. Technically, this is the connection to ground. This is the connection to the LED, and this is just some wire in the middle that can be any color you want, right? So this right here is a good LED circuit. If you click on Start Simulation, when you click on Start Simulation, it turned your battery pack on for you, which was very nice of them. But you can turn it on and off with this button here. So this is a properly made LED circuit. Now what I want you to do, just to kind of practice, see if you can practice those skills that we just did and make a bad LED circuit right next to it. So bring over another LED. I know you could duplicate that one, but bring over another one. Bring over another battery pack. Change the color of the LED as you see fit. Set up the battery pack to have the right features to look just like that one. And this time, just for fun, connect it with no resistor. So just make the wire go from the cathode straight to the negative terminal of the battery. And once you build that, we'll see what happens when you run your simulation. So take a minute and try to make that happen. All right, so I'll go ahead and do it really quick, but hopefully you were successful in that. So I added an LED, and then I added just one battery, but then I switch it to 4, and I switch it to have a switch. That's how I did that. If you try to run the simulation right now, your LED doesn't do much because I forgot the wires, right? So make sure you add wires. And the wires that I'm going to add this time, I'm going to do it wrong. I'm going to add a red one, which I happen to know is color 2, and a black one, which I happen to know is color 1. I just used the hotkeys to save myself time, right? And so now, if you start your simulation, this is a bad thing, right? So it says the current through the LED is 487 milliamps, while the absolute maximum is 20 milliamps, right? And so we didn't size our resistor right, and it warns you that this is bad for LEDs, right? Cool, so that's all I wanted to do with this one. I just wanted to get you a little practice, adding some things and adding some wires. And now we're gonna do something a lot more complex. So my LED is now done. If you wanted to, you could share it. There's different things you could do to share it. I'm not that worried about it just yet. So go ahead and go back to your dashboard. The easiest way to get there is to click on the little Tinker logo. And everybody always asks, how do I save that LED thing? It's like, well, it gets saved automatically. All right, so go ahead and click on New Circuit, and we're going to start the actual factual thing we're doing today, and that is to build the stoplight, where if I press this button, it'll go through green and then yellow, red. That's our goal today. So our last circuit was just like batteries and LEDs, and that was all good. But really, what Tinkercad Simulator is for is it's for simulating Arduino circuits. So the first thing I want you to do is I want you to drag an Arduino Uno R3 out from the side and put it right onto your canvas. The next thing that I like to do is I like to rotate it. So I like to look at it this way. It makes the text way easier for my eyes to read. Oh, actually, you could change the name of it as well. I'm going to call it My Stoplight. You don't have to start every program with the word my, but you certainly can if you'd like. In addition to the Arduino Uno, most people use these breadboards. So go ahead and drag a breadboard from the component area over to your workspace, and then hit R a couple times. Usually this is how people kind of set up their board. So they put an Arduino Uno right next to the breadboard. No shock, that's what the good people at SparkFun did as well, right? And they even put a little backing piece, right? So pretty common way to set up things. And the reason breadboards are so popular is because it's really hard, even with the last circuit we did, to hold a bunch of wires. I can hold about 2 and then I run out of hands. And so people plug them into these breadboards, and that's a great way to make connections. So now what we're going to do is we're going to make another LED circuit. So go ahead and take an LED. I'm going to put it somewhere near the top. And I'm going to rotate it until it's sideways. And I'm going to pop it right into the breadboard. And now this is analogous to physically like taking an LED and putting it in the breadboard. So I really like that. And the way this works is whenever I plug it into the breadboard, I can then plug a wire in anywhere to this row, and it's like I'm holding it to that leg of the LED. So what I want to do is I want to take this leg right here, and this is the side I'd normally put, so this is my anode side. This is the one I'd normally put to a battery, but I'm going to connect it over to, I think I'll use pin, I'll use pin 4. Really, you could use about any pin you wanted on this side, 0 through 13. The ones over here are used for different things. They're used for analog things. But I just want to connect this to pin 4. If you would like, this is a red LED, so you could choose to make the wire red if you want. It's completely optional. Also, depending on your level of OCD-ness in your life, you can choose to double-click on it and add bin points. And you can make it, as pretty as you would like. Prettiness doesn't matter. If your wires are a jumble, it still works. But you could choose to make it pretty if you'd like. Next, we need to add a resistor. Now what I'm going to do with the resistor is this. I'm going to put it on my breadboard. And so by putting it here, so I very specifically put it in this exact spot. By putting it here, that connects the top of the resistor to the cathode of the LED. And then the bottom, I'm going to connect to this ground rail that's right here. I like to make my ground rails black, so I'll make it black. Also, again, being very OCD, I'm going to add little bins so that it kind of looks like it's connected to the black one and doesn't like shoot over the top of a red one. Again, that doesn't really matter. So here's what I'm doing now. I've got power that's going to come from pin 4. An Arduino has this ability to kind of like be like a battery to where it provides power or not. And it's going to go into my anode. It's going to flow through my LED. It's going to flow through my resistor, which is currently the wrong size. And it's going to flow into this ground rail. Now there's 2 things we need to fix. One thing we need to fix is this ground rail isn't magic. It's not connected to ground magically. You have to actually connect it to ground somewhere. So what I'm going to do is I'm going to connect it from right here to the GND that's right over here. GND is short for ground. So my Arduino board is going to get power from the computer, and it's going to be basically my battery that can be turned on and off. This black wire here, by the way, it's connected through this rail to this wire so that it goes to ground there. The other thing I want to fix is I want a different size resistor. Instead of 1 kilo ohm, I'm going to switch it to regular old ohms and use 330. Cool. So now I have an LED circuit connected to pin 4. If I start my simulation though, you'll notice that my light does not go on and off. Interestingly, there is a light that is going on and off though. There's a little light right here that's going on and off. That's kind of cool. How's that? Why is that doing that? Let's go look at the code to figure out why that's doing that. So click on code. So whenever you brought over your Arduino, it actually had some code for you. And the code that it has is using the blocks mode. Again, you can use blocks plus text, or text. Today I'm going to primarily use blocks plus text. The only downside of blocks plus text is it does take up like most of your screen. But here's what blocks plus text does well. It lets you use blocks. So this is your tool palette, and then this is your code. But it lets you see the text that gets typed. And this would be a good transition for tomorrow when we just go straight into the text, right? But the reason that this light is flashing is because there's this code that says set the built-in LED, that's this little guy right here, to high, wait for a second, and then set it to low and wait for a second. You can also see that in the text over here. There was a setup function. Somebody made pin 13 an output. So pin 13, that's this pin right here, it actually is controlling this LED. And it's going high, wait for a second, low, wait for a second. And if you wanted to, you could modify it. You can make it be low for 3 seconds. And you can see how changing the blocks changes the code instantly. So that's why it's going high, and then right now it's going low for 3 seconds, because I just changed that, and then high, and then back off. I don't want to turn that light on and off, though. I want to turn this light over here on and off. So what I'm going to do is, I'll tell you what, I'm just going to trash their code. So you can see that this is now empty over here. And I'm going to bring in my own code. And what I want to do is I want to set pin 4 to high. And then I want to wait for a second. A wait is over in control. So I'm going to wait for a second. And then back into outputs. And then I'm going to set pin 4 to low. So you can see that blocks are nice because there's less errors that you can make as you're getting started. But it is also nice to see the code because that'll teach you how to use Arduinos in the wild, right? And then after I go low, I'm going to set this to wait for 1 second as well. Great. So now I've got my code here. So set pin 4 high, wait for a second. Set pin 4 low, wait for a second. By the way, some people ask, what's the difference between this one where it says set pin blank to high versus this one, set pin this to 0. This one right here is for an analog write. And you can kind of see the code that's up over there. And that's not what we want right now. We want to set it all the way high or all the way low. So if you start your simulation now, I know it's crammed way over in the corner, but you should have this light go on and off. On, off, on, off. Cool. Not too bad. Let's build some more. While I'm building more, I want my code to kind of hide to give me more space. So I'm just going to press that button for code. It'll just kind of hide over there. It's not gone. And what I want you to do is I want you to see if you can build 2 more LED circuits. Maybe put one in about the middle, put one kind of near the bottom, but not all the way at the bottom because I need to leave room for a button. But see if you can make the middle one be a yellow light. And then make the bottom one be a green light. So what I'm going to do is I'm going to not show you how I do it, and I'm going to let you do it on your own. You can optionally make the wires yellow and green as appropriate, but again, remember that doesn't actually matter. So go ahead and pause the video, go make it happen on your own. All right, so I've got my beautiful circuit here, and if I run the simulation, obviously it just does the red light still. But I'm hoping that I've wired the rest of these correctly, and now I can write code for them as well. So let's go ahead and write some code and test to see whether we've done anything useful or at all. So what I want to do is I'm going to start off by just making them all go high. Oops, that was the wrong command. I want to make them all go high together and then all go low together and just see if that works. So I'm going to grab this set pin high. So my goal is to make them all go high and then make them all go low. So here's what I'm going to do. I'm going to get some commands ready. Now I'm going to set the arguments on them. So I'm going to make 4, 3, and 2. So 4, 3, 2 be high, high, high. And then I'm going to make 4, 3, 2 be low, low, low. High, high, high. Low, low, low. And now if I start my simulation, I can test to see whether my wires are correct. And if my wires are correct, I should see flashing red, yellow, green kind of all together. I'm curious to see how my camper's doing over here. How's it going, sis?
Good.
I don't know, let's see what hers looks like. Oh, her wires are in a jumble. So not an
No, they're not.
Not an OCD print. Hey, it's working great though, isn't it? Red, yellow, green, on. Looks perfect. Way to go, sis. All right, so let's write some more code. So let's make it kind of look like there's a pattern, right? So let's make it look like it goes green, yellow, red, green, yellow, red. So you can pause the video and see if you can do that on your own, but I'll go ahead and show you this one with you. So right now, if we wanted green, well, green would be turning on just pin 2. So pin 2, it's hard to see everything at once, right? Pin 2 is my green one. So if I turn on just pin 2, so low, low, high, and then yellow would be a low, high, low. And then the last one, so I guess I kind of need another set here. So I was sneaky. I did a duplicate of the bottom 4 lines. And then the last one is high, low, low. So high, low, low. So what this should do is this should go through a little simulation where it's green, yellow, red, green, yellow, red. Cool. So the last thing I want to do, so I'm almost there, is I want it to only do like green, yellow, red after I push the button. So I want to push the button and have it go green, yellow, and then red, and then just stay at red until I push the button again. So we're doing great. So LEDs are the most common things that you'll wire up. The next most common thing that you'll wire up are push buttons. So let's go ahead and stop the simulation, hide the code, and let's go ahead and add a push button. So here's a push button. Push buttons are sneaky. They've actually got 4 legs, it would appear, but actually there's only 2, right? So these 2, top and bottom that I see here, they're actually connected by a piece of metal inside. And what you have to do is you have to put them on your breadboard in a certain way, and it's not this way because it won't even spread the middle. You've got to rotate it, so I'm going to hit R, R, R. So my push button, I brought it over and I hit R, 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 and now it should fit right into my breadboard. And what's actually happening here is there's a top to the switch. So this top is actually all connected together by a piece of metal that's inside. And then there's a bottom to the switch, which is all together. And the way this works is there's literally a piece of metal in the button. And when you press that piece of metal down, it connects the metal on the top and the metal on the bottom, and it lets it be connected like a wire. And when you're not touching the button, there's no metal connection. So it's just like 2 wires that are either touching when you press the button or not touching. And that stops current flow or allows it. So what we're going to do is we're going to connect the bottom to ground, and then the top I'm going to connect to pin 0 over here. And I'm going to make it blue. It's kind of funny, instead of using that, I like the hotkeys, but I couldn't remember which one blue was, so I just guessed a whole bunch, right? All right, so we've got a push button that's now connected to pin 0. And the way this works is internally, the Arduino Uno is going to pull it to 5 volts if you don't press the button. But whenever you press the button, it's going to take this blue wire and it's going to connect it to ground, right? So it's kind of interesting that a push button, at least on Arduino, is when you press it, that makes it low. So a press is a low, and then a not press is a high. That's backwards of how some people think. All right, so we made a circuit, which is how Arduinos work, and then we test it with code. So what we want to do is we want to check if somebody presses that button. A check is a if statement. So go to Control, find the if statement. And I'll tell you what, I'll go ahead and wrap the if statement around my whole thing. So if you move it into just the right position, it wraps it around the whole thing. Now I don't really want the whole thing in here. I just want the green and yellow part inside of here. And then this bottom part, the red part, I can just take it off, right? And in fact, this bottom weight I don't actually need. So I did a couple changes quickly there, but I think you can see my code to kind of understand what's going on here. So if you press this button, then show me green for a second. Maybe you can make that like 3 seconds. And then show me yellow for 1 second, and then go back to just showing me red. And so the thing we're missing is we're missing a condition here for our if. You can actually look at our code and see it's like, hey, we're kind of missing a condition right there for our if. Let's go, we want to see if that input is equal to 0. So what I'm going to do is I'm going to go into math first. You'll notice that this is kind of a triangular, like hexagon-y looking shape. I want the one that's a hexagon-y looking shape out of math. It's the second one down. And what I want to do is I want to check if my input, so I want to read digital pin 0. I want to see if he is equal to, so there's equal to, I want to see if he's equal to 0, because 0 is a press. And so if my button is pressed, then show me green, wait for 3 seconds, show me yellow, wait for 1 second, and then go back to red. Time to try it. So if you run your simulation, what should happen is it should just be a solid red LED. And then if you press your button, so if I press the button here, it goes green, and then yellow, and then red. So that's exactly what this circuit was doing. When you press the button, it goes green for a little bit. And then after your green cycle is done, it goes yellow and red. And the cool thing about Tinkercad is it really is just a real circuit. So the way that I programmed that board right there is I literally just took my code right here, copied it to my clipboard, and I opened up a program called the Arduino IDE, and I just pasted it inside of here, right? So I think I already had it in here from when I did it earlier. Paste it inside of here, and then I program it to my board. I'll tell you what, I want to like show that it's really my code. I'll tell you what, we'll make the green cycle be like crazy long. We'll use like 7 seconds on the green cycle. So we'll know that it's actually the latest code because it'll have that crazy long green cycle. So now this new code is on my board. And so when I press it, it's going to be green for 7 seconds. So I'm going to guess 3, 2, 1, switch. Yeah, that's pretty good. Yellow and then red. So that is what we're building today. I love Tinkercad circuits. It is such a good simulator. We use it in college classes, right? Like when we're teaching microcontrollers, because you can do everything in a virtual environment, and you can learn even if you don't have any hardware. It's great for online learning like we're doing here, and that is what we're up to today. So come back tomorrow to learn some more about circuits. Obviously, if you want to play with circuits, just create something and start goofing around. We'll try to do some fun things tomorrow too that I think you'll really enjoy. McKinley, did you have fun today? Mm-hmm. Did you get your finished circuit working? Nope. Okay, I'll help McKinley fix hers, and I'll see you tomorrow. Bye.